Welcome to iKnowva Science, where curiosity sparks discovery. Subscribe and join the journey.
Have you ever walked into a room and forgotten why you went there? Or struggled to remember where you parked your car? As we get older, these little lapses in memory become more common, but what if they're connected to something much deeper inside the brain? Scientists at Stanford University have discovered that our brain has its very own internal GPS, and in some people, this navigation system stays strong even into old age. Understanding why could change how we think about aging and memory forever. Before we dive into what the scientists found, let's start with a simple question. How does the brain actually know where we are in the world? Deep in the brain, there's a small but powerful area called the medial entorhinal cortex. Think of it as your mind's built-in GPS. It helps you create mental maps of your surroundings, where your home is, where the kitchen sits, or which turn leads to your favorite cafe. This brain region contains special nerve cells called grid cells. These cells fire in precise geometric patterns, forming a mental grid almost like drawing invisible lines of latitude and longitude inside your head. Whenever you move through space, these grid cells light up to tell you where you are and how to get back. But as we age, this system doesn't always function as smoothly. The brain's signals become less stable, and its internal maps begin to blur. That's why older adults often find it harder to navigate new places, even though familiar spaces like their home still feel easy to recall. Scientists call this gradual loss of spatial memory, the ability to remember where, one of the earliest signs of cognitive aging. So, what actually happens inside the brain when this internal GPS starts to fail? That's the question Stanford scientists set out to answer. The researchers studied mice at 3 life stages: young, middle-aged, and old, roughly equal to human ages of 20, 50, and 80 years. To explore how their spatial memory worked, they placed the mice in a virtual reality maze. Each mouse ran on a small ball while surrounded by screens that displayed a virtual world. The mice learned to find hidden drops of water, their reward, by remembering where they were located on the digital track. At first, all mice could learn the routes after some practice. Their grid cells fired in consistent patterns, as if they were building accurate mental maps of the maze. But things changed when the scientists made the task harder. They switched between 2 different virtual tracks that the mice had already learned, each with a different reward location. Suddenly, the older mice became confused. They couldn't tell which track they were on, and their grid cells fired unpredictably. It was as if their brain's GPS had lost its signal. In contrast, the young and middle-aged mice performed almost perfectly. Their brain activity quickly adjusted, forming distinct and stable maps for each environment. This showed that the brain's mapping system remains strong through middle age, but starts to break down later in life. But here's where the story takes an unexpected turn. Not every old mouse lost its sense of direction. Among the elderly mice, one stood out. This mouse performed just as well as the young ones, remembering every track perfectly. When scientists examined its brain, they discovered that its grid cells were still firing in sharp, stable patterns. This mouse was a super-ager, a rare example of an older brain that retained youthful navigation abilities. To understand why, researchers looked at the animal's genes. They found that certain genes, like haplin 4, were linked to stronger support structures around neurons called perineuronal nets. These networks may help keep brain circuits stable, preserving spatial memory and preventing the brain's GPS from fading with age. Interestingly, other genes appeared more active in mice whose grid cells had become unstable, suggesting that some brains might naturally compensate for decline while others cannot. This discovery reflects something we see in humans too. While many older people struggle with memory or navigation, some stay mentally sharp for decades. Scientists believe that studying these super-agers could reveal biological clues to protect cognitive function in everyone. Now that we understand how the brain's GPS works and why it sometimes fails, what does this mean for the rest of us? The findings from Stanford offer more than just an explanation, they offer hope. They show that memory loss isn't always inevitable. Some brains can resist the effects of aging, and by studying how they do it, scientists may one day find ways to keep our minds sharp throughout life. This doesn't mean there's a cure for memory decline, but it does suggest that our brains are more adaptable than we once believed. Understanding how grid cells, genes, and neural stability interact could lead to new strategies to support healthy aging, from better brain training to lifestyle habits that strengthen neural resilience. So next time you forget where you left your keys, remember, your brain's GPS is a remarkable system that works tirelessly to guide you through life. And thanks to research like this, we're beginning to learn how to keep that signal strong, no matter how old we get.
Subscribe to iKnowva Science. See you in the next video.